Today I'm going to be talking about ions and ionic compounds. This is section 2.7 in the AP Chemistry textbook. So ions are an electrically charged particle. You can have either a cation, which is positive. I like to think of a little cat, or an anion, which is a negative and a negatively charged particle. So ions may behave very differently than the atom they are derived from, and this is because of the change in charge. They could also be very reactive. So most atoms do this. The net charge is represented by a superscript, which is the little X you see, so it goes above the chemical name. Plus one, so you can have many different charges, but plus one means the loss of one electron, plus two means the loss of two electrons, and plus three means the loss of three electrons, and so on. So if you have a plus, you have an extra electron, and they're trying to get rid of it. So 0 means neutral. -1 means they are looking the gain of one electron, so they're missing an electron. -2 means they're trying to gain two electrons, or they're missing two, and -3 means they're trying to gain three electrons, and so on. So for periodic trends, in general, metal atoms tend to lose electrons to form cations. So that's on the left side of the periodic table, those elements. And non-metal atoms tend to gain electrons to form anions. So that's your right side of the periodic table. Thus, ionic compounds tend to be composed of both metal cations and non-metal anions. So you could have like Na plus Cl, or Ca plus At if you wanted. So a polyatomic ion, you should already know most of them from honors chemistry, but they are ions that have a group with two or more atoms. So think SO4, SO4 2 minus, or C2H3O2 minus. Those are your polyatomic ions, and you have to know that they stay together when they bond with a different atom. So the noble gases are very unreactive because they have no charge. This is the group 18 in the periodic table. Noble gas electrons are very, very stable, so all the other atoms want to be in the noble gas family. So chlorine is going to gain an electron to become argon. This one, astenine, is going to become radon. Like, they're trying to either gain or lose an electron to get to a noble gas configuration. So how to use the periodic table is the elements in 1A have a +1, 2A have a +2, 3A have +3, 4A have plus or -4, 5A have -3, 6A -2, 7A -1, and 8A 0. Okay, so ionic compounds are a compound composed of two or more cations and anions. So this is an electron transfer. Oops. Okay. So opposite charges attract, and you can tell if a compound is ionic or molecular from its composition. So if it has a metal and a nonmetal, it's ionic, and if it has two nonmetals, it's molecular. So the general rule is cations are metal ions and anions are nonmetal ions, as I've said. Ionic compounds are combinations of metals and nonmetals. So you have to know the charges of the ions, but the easiest way to write the formulas are using the crisscross method. So when you have two atoms with charges, as you see I have Na and Cl, I know that Na has a +1 charge from the periodic table, and I know that Cl has a -1 charge. So these atoms are going to bond in a 1-to-1 ratio because they have the same charge. So they're going to end up NaCl, but it's really Na1Cl1. We just don't write the ones. Next, I have one that's a little bit more complicated, but not too bad. So I have Ca2 plus and Cl1 minus. So I have a 1 for every 1 Ca, I need 2 Cls. So I'm going to have a 1-to-2 ratio. So over here, I have CaCl2. This is really Ca1Cl2. So for some practice problems, the first one is give the chemical symbol, including superscript, indicating mass numbers for the ion with 22 protons, 26 neutrons, and 19 electrons. So this goes back to when I first started, but you're going to have to use your periodic table to find what element has 22 protons, and that would be Ti. So I know my base is going to be Ti. Next, I know that mass number is protons, neutrons plus protons. So 22 plus 26 equals 28. And that goes up in the upper left-hand corner. Oh, I'm sorry, that equals 48. And so I have 19 electrons, but it has more protons than electrons. Since protons are positive, it's going to have an overall positive charge. And I have 3 less electrons, so I'm going to have a 3 plus charge. Okay, so pause the video and then try the next one. Okay, so the next one, I know I have sulfur already. I have 16 neutrons plus 16 protons, which equals 32 mass. And then I also have 18 electrons, but I only have 16 protons, so I'm going to know I have a 2 minus. Okay, next, predict the charge expected for the most stable ion of barium and oxygen. So for barium, I know it is Ba, but it's in the 2 plus column, so I will have a 2 plus charge. Next, I have oxygen, which is in the 2 minus column, or 6A. So it'll have a 2 minus charge for the most stable versions. Okay, so I'll do the first two, and then you'll do the second two. So the first one, I'm going to predict which will be ionic. So if I remember, ionic has to be a metal and a nonmetal. And my other choice is molecular, and a molecular can have 2 nonmetals. So looking at the first one, I have nitrogen, which I know is a nonmetal, that's a gas. And I also have oxygen, which I also know is a gas. So this is molecular, not ionic. Okay, looking at the next one, I have Na2O, and I know Na is a metal. It's in the 1A column. And I also have O, which is a nonmetal. So this would be ionic. Okay, pause the video here and try the next two. Okay, moving on to the next two, I have CaCl2, which is a metal and a nonmetal. So it'll be ionic. I also have SF2, which is molecular because those are both nonmetals. Okay, and finally, write the compound formed. So this is using the crisscross method, and I'll show you the first one and you'll do the next two. So for Al, 3 plus, and Cl, I know it'll react. For every 1 Als, I need 3 Cls. So I'm going to have Al3 plus and Cl1 minus. Crisscross charges, and you'll end up with AlCl3. Okay, pause the video here and then come back when you want to see the next two. So for Al, I'm going to just crisscross my charges. So that's what that one should look like. And because this is a polyatomic ion, I know this is going to stay together. So this one is going to go Mg, but since there's no charge, I'm going to have to write the polyatomic ion in the parentheses because it's staying together, and the overall charge, this 2, is getting distributed to both the oxygen and the nitrogen. Okay, I hope that helped.